Okay folks, we're going to continue our work on trig equations, and we're going to involve some factorising within this and some exact values work probably as well. Okay, let's get straight into example 1. We're going to solve 3 sin squared x minus 4 sin x. Try that again. 3 sin squared x minus 4 sin x plus 1 is equal to 0, and we're looking for solutions that lie between 0 and 360. Okay. Now, our first move is to identify what we've got here. Right, that is a quadratic, and it's an equation, so it's a quadratic equation, but it's also got some trig in it, so I would call that a trigonometric quadratic equation. Now, what we're going to do then is we're going to use some of the elements of what we've learned from trig equations already with higher maths, but we're also going to put into play some prior work that we know from National 5, which is going to involve factorising the quadratic. Okay. So let's see how we're going to go about that. Right. Okay. Now what I'm going to do is I'm going to liken 3 sin squared x minus 4 sin x plus 1 equals 0 to 3x squared minus 4x plus 1 is equal to 0. Now, hopefully you would agree that that kind of looks like that, although that's got sin x in it and that's got x. You may have noticed at the very start when I scrubbed that out, it's because I was about to write 4x instead of sin x. Right, so we're going to liken that to that. Now, if we can factorise that, I think we can factorise that, because really what I've just did there is I've replaced sin x with x. Okay, sin x with x, sin squared x with x squared. Okay, so if we can get this bit factorised, I think it's going to be fairly easy to transform to get that bit factorised. Okay, so that's a bit of National 5 work. So 3 times 3 times 1 is 3 rather. Two numbers that multiply give 3, add together give minus 4 is minus 3 minus 1. Minus 3 times minus 1 is plus 3, minus 3 minus 1 is minus 4. So I'm going to generate then a pair of brackets. Minus 3 minus 1. Drop 3x into here, drop 3x into here. Now, it's then a question of can I factorise further? Well, I can take out a common factor of 3 there, and I can't do anything with the second bracket. So the second bracket, I just write it down again. First bracket, I've taken out a common factor of 3, so 3 into 3x goes x, and 3 into 3 goes 1. Okay, now, what I'm now going to do is bring back the trig stuff. So really what I've did there is I've just quickly and kind of informally replaced x with sin x. Alright, so x minus 1, I can now write that as sin x minus 1. And then 3x minus 1, I can write that as 3 sin x minus 1. And that's equal to 0. Okay, now what I've got now is that could be 0 or that could be 0. So what I've got then is another example of 2 trig equations. So I'm going to put a line down the page and solve each in turn. So the first one then, sin x minus 1 is equal to 0. Put the cast diagram. Remember it's degrees with this one. I said that at the start. Okay, bring that across. Sin x equals 1. X equals sin inverse 1. Okay, right, so we're in the all quadrant and the sine quadrant. So sin inverse 1, right, that's one of your exact values. That's 90 degrees, that's my all quadrant solution. So for the sine quadrant, it's going to be 180 take away 90. and it just so happens that that will give me the same result as 90 again, so I don't need to write it down twice. Okay, right, so that's that bit done. Now let's do this bit. 3 sine x minus 1 is equal to 0. Notice I didn't pick up a calculator here, but I'm going to have to pick up a calculator here because this is not an exact value. I'll then get 3 sine x equals 1, and then I've got sine x equals 1 over 3. Okay, cast diagram. 0, 90, 180, 270, and 360. Okay, so it's sine, it's all in sine. Okay, and then it's x equals sine inverse 1 over 3. Now you might have been on radians mode last time you calculator, maybe you were, maybe you weren't, but make sure you're back on degrees mode and punch that into your calculator. Okay, and that should give you 19.5 degrees. That is my all quadrant solution. Okay, in the sine quadrant there's going to be 180 take away that, so 180 take away 19.5, and that's going to be 160.5 degrees. Okay, final move, let's put everything in numerical order. X equals 19.5 degrees, 90 degrees, 160.5 degrees, final answer. Okay, let's go question 2. Question 2. We've got tan squared theta plus tan theta minus 12 is equal to 0. And we're looking for solutions that lie between 0 and 2 pi. So this time, let's get the calculator into radians mode. And if it's not a radians question, then we don't need the calculator, but we still know that we're working with radians rather than degrees. Okay, right. Okay, the first thing that I'm going to do again is I want to factorise that, because that looks to me to be a quadratic trig equation. Okay, so I'm going to liken tan squared theta plus tan theta minus 12 equals 0. So you can see that that kind of looks like x squared plus x minus 12. And really what I've said there then is that tan theta is x. Okay, so I'm looking for two numbers multiply, give minus 12, vertically give plus 1. And that's going to be x plus 4 bracket x minus 3. Let's bring that back in and bring the trig back in. That's going to be tan theta plus 4 bracket tan theta minus 3 equals 0. I've then got tan theta plus 4 equals 0, line down the page, and tan theta minus 3 is equal to 0. Okay, right. Let's bring that over. Tan theta equals minus 4. Let's get the cast diagram down. Zero, pi over 2, pi, 3 pi over 2, 2 pi. Okay, so what's my next move? My next move is to make the negative result positive. That's my routine. And instead of looking, I would normally look in all and tan, but I'm going to look in sine and cos. Okay, so it's then theta equals tan inverse 4. Now that is a calculator question, so let's just make sure that we are in radians mode, because we're looking for solutions that lie between 0 and 2 pi, and 2 pi is a measurement of radians. Okay, and in 1 decimal place, that will give me 1.3 radians. Okay, now remember, I was just about to move on and make a mistake there. The first answer that I get is always the all quadrant answer. Now I'm not in null quadrant, so that's not a solution. I'm in the sign quadrant. So the sign quadrant is telling me to do pi take away 1.3, so that's 3.14 take away 1.3. Okay, in one decimal place that is 1.8 radians. I'm also in the cosine quadrant, so remember in the cosine quadrant then it's 2 pi take away 1.3 into one decimal place, then that's going to give me 5.0. Okay, right, let's move across to here. Bring the minus 3 across and that will become 3. So I've now got tan theta is equal to 3, and then it's theta equals tan inverse 3. Put up the cast diagram. Record everything as radians. Okay, now this time tan's positive, so I'm in all in tan. Okay, another calculator question. So theta is equal to tan inverse 3. Let's put that into the calculator then. Into one decimal place, that will give me 1.2 radians. I'm also in the tan quadrant, so the tan quadrant is telling me to do pi plus 3.14 plus the 1.2 radians. And to one decimal place then that will give me 4.3 radians. Okay, final move is I'm just going to put everything in numerical order then. So it's going to be 1.2, 1.8, 4.3 and 5.0 radians. Final answer. Okay, let's try an example 3. Okay, example 3, and we have 3 cos squared x is equal to 2 cos x plus 1. We're looking for solutions that lie between 0 and 2 pi. Okay, so we're radians again, so let's get calculating radians mode. If it turns out to be a calculator equation, 3 cos squared x minus 2 cos x minus 1 equals 0. Now this is the first move that I've made there. Well, we already know that if you're solving a quadratic equation, and if it's an algebraic quadratic equation or if it's a trig quadratic equation, well, the same rules apply to get going, which is the thing must be equal to 0. So I'm going to bring that across, make it minus. I'm going to bring that across, make it minus, change its sign. Okay, I'm then going to liken 3 cos squared x minus 2 cos x minus 1 is equal to 0. I'm going to liken that to 3x squared minus 2x minus 1 equals 0. Okay, so let's factorise this then. 3 times minus 1 is minus 3. Two numbers that multiply give minus 3, and that together give minus 2. That's going to be minus 3 and 1. Okay, let's get my 2 brackets in the go. That's going to be 3x minus 3 and 3x plus 1. Common factor of 3 brings that down to x minus 1. 3 into 3x equals x, 3 into 3 equals 1, and 3x plus 1 is equal to 0. Okay, let's bring it back in with the trig in it. So that's going to be cos x minus 1 bracket 3 cos x plus 1 is equal to 0. Okay, next move, let's get a line down the page. And over here I've got cos x minus 1 equals 0, and over here I've got 3 cos x plus 1 is equal to 0. Okay, so it's going to be cos x equals 1. Let's get the cast diagram up, and let's continue on with this one. Okay, so 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so I'm in the all quadrant and the cosine quadrant. X equals cos inverse 1. Okay, so what's my exact value there? Well, my exact value there is 0. Okay, so that's my all quadrant solution. So for the cosine quadrant, then it's going to be 2 pi take away that. So 2 pi take away 0, and that is 2 pi. Okay, over here, 3 cos equals minus 1. Cos x equals minus 1 over 3. Let's make that positive. And let's get the cast diagram up. Okay. So, this time I've changed from negative to positive, so I'm in sine and tan. X equals cos inverse 1 over 3. That is definitely a calculator equation. Make sure you're in radians mode. Okay, so that is 1.2 radians. Okay, however, that's not a solution because I'm not in the all quadrant, so score it out. So instead I look in the sine quadrant, which is going to be 3.14 pi, take away 1.2, and that will give me 1.9 radians. I'm also in the tan quadrant, so the tan quadrant is 3.14 plus 1.2. Okay, pi plus 1.2, 3.14 plus 1.2, and that will give me 4.3 radians. Okay, final move. Let's put things in order. Excuse me. So it's going to be 0, 1.9, 4.3, and 2 pi. That's about 6.2, so that'll be the last one. Final answer.